Hello, physics. Today topic is a parallel universe or multi-universes. Uh, the prediction of future we can based on two mechanics. One is a classical mechanics, which is based on Newton's laws of physics, Kepler laws of physics, and other laws of physics, mostly uh, Newton's laws. F is equal to ma. F is equal to 0, which is first law. F is equal to m is second law. F is equal to minus f, third law. So for which the properties of the material which are fixed, like mass, velocity, uh, we know this one, and is momentum. So we have an initial state, and we can predict the final state based on these laws. So this is a deterministic mechanism. So we definitely know what is the absolute, what will be the value, absolute value of the S position. So we can use the Surratt uh, um, equations. So these are also useful. So we will apply these. We can apply these laws or equations on projectile, planets, stars, galaxies, and then we can be able to predict its final state. But on the other hand, this is a quantum mechanics, and quantum mechanics, uh, the state of small particles or waves. So it is in the form of a wave function. So when it's a wave function, and then we have instead of Newton's law, we start from the Schrodinger wave equation, and the future of the particle is written as the Hamiltonian. So is in this form. So h psi is a wave function. I imaginary number, h cut Planck's constant by 2 pi, and the time derivative of the phi wave function. But we cannot. This is the wave function. We cannot observe. This is the wave function, which is psi. So RT, space and time. So we cannot observe the wave function unless we have to do something else. So this is a wave function. When we observe this, it is collapsed. It is a square of the amplitude. The measure to measure the wave function of the single point in space, the wave function is spread as in a space and time as a Schrodinger wave equation, but its detection is a single point-like detection, which is a spike. So the fact is that this wave function is stem from de Broglie idea of that matter has a wave-like properties. So a photon can act like a wave. That means it have a wavelength, frequency, velocity, amplitude, etc. So and also photon behave like a particle. It have a mass, it have velocity, so such that this one. So but how we can measure this the uh, uh, wave function, which is based on the Schrodinger wave equation and the Broglie idea. So if the particle is behaving like a wave, so it has a wave function. So wave function, how can we observe it? How should we interpret the wave function? So ideas de Broglie, so and Schrodinger and Max Born. Max Born said that each point in the space, the wave function, has a complex amplitude, which is complex, mean it has a real part and also imaginary part. So the amplitude is the square, uh, the probability. So the probability is the square of amplitude. So the probability of the finding the particle in a space, some certain space in certain time, and this will give us the it will be we can calculate it from the amplitude, the probability. The core of this reality of amplitude uh, is give us the probability of finding the particle or wave. The probability is a quantum mechanics. It is not deterministic as a classical mechanics is have a certain value. So it varies. It not give us one value instead of it is give us a range of values. So on the other hand, the classical mechanics give us a certain value of the uh, final state. As Einstein was not comfortable with the quantum mechanics, that it gave us a range of possibilities. So not comfortable with the probability idea. But the thing is that the quantum mechanics is rely on the different rules, and these the two rules, two things go hand in hand with this. So quantum mechanics give you different rules when you are not looking at, when you're not observing it. The wave function involved in the Schrodinger wave equation is like a spread of the wave function. Wave. So it's like this one, spread. But when you are observing this one, the wave function collapses suddenly and irreversibly, and the probability is the square of the amplitude. The collapse of the wave function, the collapse of the wave function, the probability of the measurement of any outcome is given by the amplitude as Max Born, and it's squared. So the probability is proportional to the amplitude square. So the wave function, we observe it, the wave function, and then the amplitude square. This is the probability. So this is the first part.